Okay, welcome back. In this video, we will have a look at further Git features in order to go beyond the very simple one which we have seen in the previous lecture. So let's start. First, I would like to show you how to rename files, and this is something which could be very handy if you realize in your project that the name of the file should change for whatever reason. For example, here I want to change readme to txt, and you can use the move subcommand of Git in order to do that. So git move would rename in your working copy this file into readme.txt. Because no Git knows about that you have renamed it, Git can also record it. However, it's only recorded at the beginning at the stage. So if you make a Git status, you see that it has not been committed yet, and you need a Git commit in order to write that into the repository at the end. The next one is how to delete files, and this is very similar to renaming files. Again, if you realize that there is a file which is not necessary in the project anymore, you can use the remove rm subcommand of Git in order to delete this unnecessary file. Again, if you make a Git status, you realize that it had been only basically done on the stage, in the stage area. So in order to write that into the repository, you need the Git commit in order to make it permanent and record it in the history. There is one very important thing you should note when you are deleting, moving, or even deleting files is that usually here you have a Git history and each commit is connected to the previous one as you go along in time. Here you have your file, here you have your file, and let's assume this is the commit where you deleted the file with the git rm command. Then basically in the next commits the file won't be present anymore. However, if somebody checks out an earlier version of the project, like this commit, the file would still be there. So basically this delete statement is only refers to the past, to the not to the past, but to the future. So basically in future commits it will vanish, but in previous commits it didn't. So try to not to check in something which you don't need, because it's not so easy. There are ways to delete that backwards in history, but then you would also change history, and that's usually not very good, especially not if you are cooperating with other people. Okay. The next thing I would like to show you how to investigate changes when you make changes to your project. And let's assume we would like to find out what we changed since the last commit, since the last Git commit. And the diff command is the one which shows us the changes. And if you give diff just a file name like readme.txt, then it would give you all the changes which had been made in your working copy with respect of the last version which was checked in, which is in the repository. And you see, you get a text output here, you get a few minuses, which means those lines had been removed, and a few pluses, which means those lines had been added instead of the removed one. If you do not specify any file name, just say git diff, then it will basically affect the entire project. So you would get basically a git diff for all the files which has been changed into working directory with respect to the one which is in the repository. You can also investigate diffs between various commits which you have done before. So for example, here I'm just comparing the diff of readme.txt between two different commits. So how did it change between this and this commit? You can find out by specifying the commit IDs. Okay. However, if the changes are very complex, then it's not that if the changes are simple, then the text form is easy. If the changes are more complex, it's much better to have a graphical diff viewer which shows you the differences in a graphical form. So for example, in the previous slides, we were using melt, so I'm also using melt here. And if you are using the git diff tool command, so basically not diff, but diff tool, then this graphical viewer will be invoked in order to show you the differences. And especially if you have a more complex changes than just a few lines, if it affects several lines and some lines here, like here, had been changed, some lines had been added additionally, and so on, then the graphical visualization can help you a lot to understand what the changes exactly are. You see here even the words, single words are noted and marked, which were changed between the two revisions, between the two versions of the project. So just use the diff tool as much as you can. Usually it gives you a very, very nice and very helpful output. The next one I would like to show you is how to discard changes in the working copy, and this can also sometimes happen that basically you mess up everything and you don't know what to do anymore. So basically, just since the last commit you are just writing code and nothing works, and you somehow lost the overview why things are not working anymore, then you can say, okay, I would like to restore the original state. And this, the original state means the state how is it is stored into the repository. Then you can use the git restore command, and you can pass to the git restore command a file or a directory, and then it will basically restore the file or the content of that directory according to the last commit in the repository. Right, so you see, after I just changed git restore, I have issued git restore, git status says that the working tree is clean. That means the working tree is exactly in the same status as the project in the last commit. You have to be very careful with this git restore because it's not asking any question. It basically immediately overrides the working copy. So be careful with that command. Yes, the next one is the restore. The next version of the restore is you can also restore things in the staged area. What does it mean? It means that you have, for example, here already with git add added the changes to the stage area. So with the next commit, this change would be committed to the repository. But at some point you realize that no, this is not something you don't want to commit. So you want to remove this modified file from the stage. And then you are adding to the restore command the ---- staged option, which would basically just set it back, remove it from the stage. And if you have a look at that, you see that basically git status says it's still modified in your working copy, but basically it's vanished from changes to be committed. So basically the changes are not on the stage anymore. So if you would make a git commit, this change would not be checked in. So just give you an overview at the end about all these commands which we have. We have always three different positions in our Git workflow. One is the working copy, which is basically in our disk. Then there is the stage where we are putting all the snapshots or all the snapshots of the files which we want to at the end write to the repository. Right? With git add, as we learned, you can just transfer something from the working copy to the stage. So basically the file for which you are calling git add will be put on the stage in the state as it was in the working copy. But we know that it's not written to the repository yet. You need git commit in order to transfer that into the repository. The way back from the repository to the stage. So if something on the stage has changes and you want to destroy those changes or restore basically the stage to be look the same as the repository, then you can use the git restore ---- staged command. The same way you can use the git restore command to restore things without the ---- staged option. To restore things in your working copy, and depending whether the stage has changes or not, either the file is transferred from the stage to the working copy or from the repository to the working copy. So this should give you a small overview about the possible commands how to transfer things between working copy, stage index, and the local repository. The next thing I would like to show you how you can time travel using Git, because we were basically recording history, and one of the most important reasons why we record history in order to be able to go back into history. So there are two different definitions I would like to show you here. The first definition of the branch, and we will talk about branch later much more in detail. For the moment, basically just I think the simplest definition is that the branch is a line of history, and usually we are using only one branch in our project so far, so one line of history, and this line of history has the name main actually. This is the main line of history. And there is the other definition, the head, and the head is basically just a pointer which points to a commit. And the head can point to the latest commit of a history line, of a branch. Then we are talking about that the head is attached to main, or we can go back in history and the head can point to an earlier commit, and then we are calling it as a so-called detached head. Why is it important to know about that? Because if you are in a detached head state, then here you cannot make any comments. So you can go back and visit what was the project at this point, but you cannot make any comments because I have already a line of history and I cannot change the history. I can go back to history and visit things, but I cannot change the history. Right? So if you have a detached head state, then you cannot change things. If you're in an attached head state, then of course you can make a new commit, because the new commit will be then added to the top of the branch, to the end of the branch, and then the head will of course move forward to this new commit. Now let's have a look how you can do it with git commands and the git command to use. There are very different ways how you can do that, but the modern way is to use the git switch command, which would switch between different commits if you want. However, if you want to switch to a commit which would cause in a detached head state, then you have explicitly passed the minus detach option to tell Git, yes, I exactly know what I'm doing. I want to go back to an earlier state and I know what are the consequences. And then if you do a git status, then you see that head detached add blah blah blah. So basically you see that, okay, we are now back in history and you can visit your project at that state. If you want to make changes, you have to go back to the top of the branch, to the top of the timeline, to the latest commit on the timeline on the branch. And this you can do by using the git switch command, and again, without minus detach, and you are specifying the name of your branch, the main of your timeline. So basically if you say git switch main, then we are going back to the latest commit of main, and the head gets attached again. So if you commit something, then it will also always show to the point to the latest commit. There are also other ways of doing that. Actually, you can also spin off a branch from an earlier commit. I'm not showing it here. We will talk about that later when we are talking about branch in one of the next lectures. The other thing I would like to show you how to tag versions. Why is it important? Because we have used basically git commit IDs in order to identify various commits of the command, but this is not very nice to write, and sometimes there are specific versions you would like to, specific commits you would like to remember, like for example a release, like a commit which corresponds to a release, and you can use a symbolic name instead of the commit. And basically that you can do, let's say if you have a git log project, and here I have the different commit IDs, and then basically at the head is at this commit ID here, and now instead of writing 78CF66, I would like to write be able to write something much more simple like this. If this is version 0.1, then I would like to write just v0.0.1, right? And this I can do with the tag command. So basically, if the head is at that commit and I say git tag v0.1, then basically from that point on I can use 0.1. It has the tag 0.1, and I can use the tag 0.1 in order to identify this commit. Basically, that means that I can basically use this name instead of commits. So for example, as we have seen with the previous diff command, where I can specify two different revisions. If the revision has a symbolic name, I can use a symbolic name instead of that, and that's super nice. The only thing maybe to keep in mind is how to make the tagging. There are two different type of tags, the so-called annotated tags and the normal tags. Here I was showing you the annotated tags with the -a option. Why? Because it's a tag which is distributed with the repository. So if you are tagging a specific commit with a symbolic name like a version, then of course it's important that other people who are also cloning your repository and using your repository can use the same names. If you leave away the -a, then you can also give tags, but those tags will be only visible for you when you are working in your working directory. A very nice thing which I'm using a lot in Git, that you can basically make abbreviation. Alias is for various Git commands, and how you can do that, you can see it here. So basically you can define an alias here, an abbreviation. Let's say I'm using the abbreviation CI instead of commit. So basically you are just making a git config. If you want to make it global, then with the -- global options, and then alias dot, and then the abbreviation, and then the original commit. You can also have something more complicated, like here I'm using swd, for switch minus minus detach. Then you have to do, put it in quotes if it's a command, a more complicated command with empty space here. Or I'm using st for status, and then I'm using gdiff, graphical diff, instead of having to type diff tool. And I'm using sw for switch. And this is something you should also configure, because some of the examples which might come in the next lectures will probably use these abbreviations. And if you use this abbreviation, you can spare a lot of typing, like you can just say CI instead of check in, SWD instead of switch minus minus detach, ST, which we use a lot instead of git status, and so on and so on. And we are also using the graphical diff tool that also you can use with gdiff instead of having to write git diff tool. Okay. Talking about graphical applications, if you want to visualize the history of your project, of course you can do git log, as we have already seen, but also there are various different git clients, graphical git clients, which can make your life much easier, especially as we will see later if you have some complicated history with branches, parallel timelines of developments which were then brought together. Then it's much easier to have the overview if you can use a graphical tool. If you are using Windows, then git k, if it's one of those graphical tools, is already automatically installed with the git installed with the git bash. If you are using Linux or Mac OS, you can just install one of using the packaging system, your favorite packaging system. I would suggest either to use qgit or gitk, but if you know any other one, git viewer which you like, feel free to use that one as well. So the next thing I would like to point out is how to track remove repositories. So basically you want to participate in the development of a removed repository. Maybe at the moment just watch the development, not contribute yet. And the way of doing that is if you know where the project is deposited. For example, I have deposited here a project in my namespace on GitHub, which I just call SciPro demo. Then basically you can just make a git clone of that. That means that you are making a copy of that, a local copy of that. And if you go to the local copy, then basically, and enter in the directory which has been created. First of all, you can with git remote -v, you can just basically show whether git knows anything of the origin of this repository from remote, where it comes from. And indeed, git will introduce a new symbolic name for origin, which is nothing as just a URL of the remote repository. Later, we will have some commands where we will use this symbolic name. So for that, so it will be very practical. For the moment, you just should basically just remember that the origin is a symbolic name for the repository which you cloned. And then if you make a git status, then git also tells you that, okay, your main branch is up to date, and this main branch is up to date with the position how origin main is, which means the main branch on the remote repository, which means the main branch on main branch on GitHub in this case, which we have cloned. Of course, if you are watching the development of the project, sometimes this project hopefully will basically going forward, having newer and commits. And in the main branch, you can just say a git pull in order to pull in those commits. So basically, you can get the latest changes on the remote repository. Just a caveat, I'm not talking about that in details, but this git pull only works properly, or as you should use it, if you did not change the content of the main repository locally. We will have a look later how to collaborate with Git with other projects and how to do things. I won't go into the detail yet. Just note basically that if you don't change anything in the repository with git pull, you can easily pull the last changes from a given branch, from the main branch in this case. So, and then I would like to just make a few git notes or some random notes at the end. And the very important thing is, please read the manual, read tutorials. The git is incredibly powerful. And here we are just scratching on the surface. Maybe just a rule of thumb when to commit. And it's basically you should commit always if you made a non-trivial change. Just don't forget, you are committing in order to be able later to go back history and look at changes. So basically, it's very important that other developers or you in 2 years are order to follow and understand the changes within one commit. If you are changing 1,000 lines thousands of lines in a commit, no way that somebody can easily understand what you did. Of course, you should not commit after every line, because then it's also very useless. Usually you should put only logically related changes into one commit, right? So do not fix documentation and rewrite the program at the same time. Do them always step by step. One commit should be one logical step during your development. Each commit should have a working project, right? So the project in some form should be runnable. Otherwise, it's impossible to test it and find out whether a certain bug was in the project at that point yet or not. So make sure that every commit is a working project. And then, but you have already realized that the Git commands must be usually executed in the project directory or any subdirectory of it, because this is how Git knows on which project that to apply and where to write the changes. And just to remind you, basically the entire version history and everything which Git knows about your project is stored in a .git subdirectory of your project, which is quite nice, because if you distribute your project, you can basically distribute with the .git subdirectory, and then basically you can distribute also the history of your project. And finally, a very last note on how to have external remote Git repositories. So to provide other people access to your project, you can, if you want, if you have access to a web server which you maintain, in theory, you can just host a so-called raw Git repository on your web server and give the people the URL so that they can clone your Git repository. The other option is to use Git repositories with user-friendly web interfaces, which is very helpful. We will see examples for that later. For example, you could run on your machine, on your server, a so-called GitLab server, which provides a very nice graphical web-based interface to the repositories and makes especially cooperation on a project much smoother than if you would just have a raw Git repository. If you don't want to run your own server, then there are several companies who offer Git repository hosting with some constraints. They are free in the sense that you don't have to pay, but of course you pay either with your data or by some other mean. The three big ones are basically GitHub, which has been bought by Microsoft a few years ago. This is basically the most popular, and most of the open source projects are hosted on GitHub. The other very big player is GitLab, which is run by the GitLab Inc. Company, and Bitbucket, which is run by Atlassian. And you should maybe, if your project should be known to very many people and you want to share it with many people and you want other people to collaborate, then maybe you should think about to host your project on one of those commercial sites. And if you want to have a look, for example, you can just look at the SciPro demo repository, which we just cloned before. You can just go enter this URL in your browser, and then you will have a nice graphical representation of the project. And with that, we basically finished here the advanced Git features.